Hello, welcome to Electronic Waste Benefit. This is video number 14 of the 9th circuit, and this circuit is what I call the packer. This is an assistant for parking cars at a parking bay. And you can see you are using a microcontroller, and the microcontroller is a PIC16F877A. Zoom it so that you can see it. And I've done it in 3 ways for indication mostly. One with a LED indication in the case of simulation, or you can have some lighting arranged in 8 ways, and you have here 2 input signals, which are analog signals, but you can have to a maximum of 3 for this microcontroller. So what is critical here is to say the sensors are actually normally open when there is no car on the parking bay. If a car comes on the parking bay, the sensor closes the circuit. This is a simple summing amplifier, and I am using here a CA3240 operational amplifier. And the other important point to note is there is a negative supply. This op-amp is supplying the 2 op-amps, which is one chip, of course, is supplied by a split power supply, which meaning that it has got a negative voltage and positive voltage and a 0. You can have this power supply either buy it commercially, or you can actually construct it yourself. Refer to my circuit on the inverter video which I posted on YouTube. There is also a link to my Google Drive, which you can download these circuits. So what is critical here is the voltage that comes out of this op-amp. It must not exceed 5 volts. Remember, microcontrollers are powered by 5 volts. So you have an analog input, 2 of them, which you can actually expand to 3. I've only done 2 just for explanation purposes. The third one can take out these outputs and the third input here. Right, so what is happening, we will explain how this circuit works, but before then we go for our script. Remember, electronic waste benefit uses as much waste as possible. Now, safety first. Electricity can kill, so please make sure you know how to work with electricity. We expect that you have experience in working with electricity, and you have prior knowledge of electronics. You keep all the environment clean, away from children, and we expect the minimum age for you to do these projects to be 10 and above. So if you are younger, you can do it, but with great supervision and inspection. Right, this is just a share. It's not an electronic lesson, but a description of how this particular circuit will work. So if you are not familiar with electronics, literature is there on the internet, and you can actually learn electronics and then later on do these projects. Now use electronic waste as much as possible. 90%, 100% will be much preferable. There are better ways of doing this, and this is, well, an example of how I could myself do it. So you can correct if there are mistakes, adapt it, you can modify it, you can improve it. And this circuit's my intention is that it's used to benefit the training of electronics, and the use of this particular circuit industrially, actually, to have a practical circuit that works well, improved, and actually be applied for the benefit of society. Right, the resources required, of course, a computer, because we are going to program a microcontroller, well, operating system of your choice, or the one that works. You're going to need a programmer, of course. You can construct a JDM. Refer to my previous videos where I have actually shown how I can build a JDM programmer, or you can use a PIC2 or PIC3 for USB programming. You need a power supply, electronic components, boards for prototyping, or populated PC boards for the West, soldering iron, soldering wire, multimeter of course, electronic tools, yes, oscilloscope, but logic analyzer, maybe but not necessarily. The software, the PIC PGM is a free software you can download for burning the code into the microcontroller. Proteus development suite that I have used, you can download the trial version or buy it, or you can use any other simulation software, build, draw the circuit and use it. LD Micro is the program that I used for writing the code. You'll be provided. There is a link for you to download this whole circuit. So you can download the LD Micro from the net if you want. There are a number of versions there. People have done great job there. Now this project will need time, you'll need your patience, you'll need your passion, your dedication, and any feedback, comments and whatever. There is my email. Thank you. Welcome. I hope you enjoy electronics. This is Electronic West Benefit. So we are going to start with the circuit description. We will continue. So this is how it works. Summing amplifier in equal steps. The choice of resistors is that it follows the program, such that you have a voltage here that corresponds to the output. That voltage that comes out of the op-amp will actually be converted to digital, and you have an output there that actually shows which position is free, and only that position which is free. And this works on the priority, that it's a priority indicator, which means you only indicate the least bay that is not occupied. Like for example, if bay number 1 is not occupied, it will be shown here. Even if bay number 6 or 7 is not occupied, it will show the list. If bay number 3 is not occupied and bay number 8 is not occupied, it will show bay number 3. If bay number 6 is not occupied and then bay number 2 becomes free, but it was occupied before and becomes free, it will jump from showing bay number 6 is not occupied to bay number 2 is not occupied. So there is priority of the least bay. Same with this one. This is just a replica of the top one. So how it indicates, please remember, practical circuits, the microcontroller does not drive straight to the display like that. You would have to have interface circuits here, like the relay drivers. You drive the lighting using relays. However, the relay is you know, the ULN2803IC, a good relay driver. If for prototyping and small indication, of course you can do it this way, but this is mostly for explanation only. So the displays are actually practical road signage, and it must be able to be seen from a distance with someone who is driving. So they indicate which bay is not occupied with priority of the list, and then when the bays are full, it will show that the base is full. And each section, like a set, that set of 8 will actually show you that this bay section is full. If all are not occupied, it will show bay number 1, because that's the list in terms of the priority. So that's how this circuit works. There is a program that I'll show you how it works. And remember, main points: negative split supply for the op-amps. Why negative? Because here you have an inverting input, and you invert a negative, you will get a positive. So you need a range of 0 to 5 volts, as you will see with our simulation. So now this is why you have a negative here. You can do it with a positive if you can, it's no problem. And practically you might have to adjust these values of the resistors. The critical point is the feedback resistor. This must be a preset. Otherwise, use a preset and then later on maybe fix it. And this whole circuit must be as close as possible to the sensors. And the resistors are along the cable. They will be along the cable and at points where the bay is. The sensors, you can use load cells, which is to be mounted on the floor to sense the car, or ultrasonic sensors, or whatever sensor that can actually differentiate a vehicle from human or from pets or from any other object which is not a car. So the sensors must actually be able to sense the car, only exclusive and very selective. You research on that, but I've done a little bit. The best will be the one that actually senses the weight. And these sensors, as I said, it's a normally open sensor. If a car comes, it closes. If there is no car, it's open. So that will give a voltage output here which corresponds to the position that is not occupied, as we'll see with our simulation. Right, let's go on and I will show you. I've done this in 3 methods. First, with just a bar or an array of positions to indicate which one is not occupied in priority. The other one is okay, not very good there. It doesn't matter anyway. This is where I was working. Right. The other ones are actually you'll see them during the simulation. We are using 7 segment. They are just bit different. The other circuits are basically the same. The base and all that is the same, and only that the indication is now 7 segment. So you need drivers for the 7 segment. So after the 7 segment driver, you would need interface to drive the 7 segment, because the 7 segment will be big in practical terms. It will be size of the road signage. So this is how the other one is different. Then the third one actually is just having 1 7 segment. This one has 2 to indicate the position that is free, and when it's full it indicates here. But the other one would have just 1, which you will actually see when you are simulating. Now, first, before we simulate, we go to the program, how I did it. This is LD ladder logic. Right. So, it's using analog signal input. It converts it to digital. So, it reads the analog input. So, you have 2 sets here. The third one, you just add exactly, almost plus minus, with different, only the numbering and all that. But otherwise, looks identical like this. You just follow the pattern for the third one. As you can see, the second one is actually following that pattern. So analog read 180 greater than or equal to 180. These 180, 280 or 380 are actually parts of 5 volts. So 5 volts divided into 10 bits, that is 10, 24 parts. As you can see, 2 to the power 24 we can calculate here is actually 1024. 2 to the power 10 equals 1024, but you have 1023 because 0 is the 1024th one. So 1024 parts. So divide 5 into 1024. So this 180 is actually 180 parts of the 5 volts. These values actually correspond and must correspond to here, to these values of the resistors, the values of the voltage that comes out here. First, what I did was actually just choose these values, and then I had to actually play around with the resistors such that it will give me the corresponding output here. So these are equal steps. As you can see, the resistors are the same except that one. This one I had to adjust it to 2K. so that it gives me position number 1 if this one is opening. So a voltage here that corresponds to position 1 would need 2k here with that feedback resistor, and then this one. So well, first I tried the other 2R or the other whatever ladder. It wouldn't work. Just use equal step resistors. So right, what is critical? That feedback resistor you have to adjust so that you have that voltage. But this was working, as you see with the simulation. So actually the resistors are following this up to 980. You'll see that there are 9 resistors there. Let's see, count them: 1, 2, 3, 4, 5, 6, 7, 8, 9. It would be smart if I had written 1, 2, 3, 4, 5 resistors, but doesn't matter anyway. Okay, right, so 9 positions. So these are also 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, so to correspond with the resistors. So when the bay is full, this program is actually for the one with the circuit with one 7 segment display. I will give actually the other program as well from Google Docs, which you link from YouTube, that I will give, so that you have the program for the other ways that I have done. This one actually, yes, when there's no when all bays are occupied, you have a high output out of the microcontroller. But when one base is free, you have a low, because it's you'll see that there is a BCD converter that needs a low input. It's active low, a binary coded decimal converter, which uses a low input. So this is why it is like this. Normally I just program it the way I think, but this program works. And then when it's full, it starts to flash. Here we have a flasher, just an oscillator circuit. That's 2 Hz, 500 milliseconds. That's half a second. So it's double the frequency of 1 Hz. So that's 2 Hz. Yeah, 2 Hz. So we'll go for simulation now. So this is the program for one with a single 7 segment display. Right, let's go for the simulation now. We start with one with just an array of indicators, position indicators. The only thing that I don't like about Proteus is you can't really zoom it to the position that you want. So motorists will only see this indication, this part, the indicator. This part and that section is identical, so talk of just one side, although we will actually switch between the two, but mainly it's the same. So this is actually telling me that bay number 4 is free, but it doesn't tell me that 5 is free or is occupied. It's only showing me that the next in priority order is number 4. 4 is free, and yeah, it tells me that that whole bay is full. This is full basic indication. So if I go to my sensors and I open bay number 6, it doesn't change here because it's still having a priority sensing. But if I open bay number 2, it will change to number 2 because number 2 is lower than 4. Right, this bay 4-1. Right, the 1-1, 2-1, 3-1. I just chose sometimes a system to indicate which section is it. But this is set number 1. This is set number 2. So this one will be 1, 2, 2, 2, indicating it's bay number 1, section 2. Bay number 2, section 2. This is bay number 1, section 1. Bay number 2, section 1. That's in the convention of numbering, not very important. It is actually bay number 1, 2 up to 8, bay number 1 up to 8 for section 2, right? So if a car comes and occupies that one, it will show that 4 now is still not occupied. If a car comes on 4, it goes to show that 6 is free. So if 8 is free, it will not show because 6 is still free. Suppose 3 becomes open, it means it will show 3, and 3 becomes occupied, goes back to 6. 6 getting occupied goes to 8. All occupied shows it's full. And that one, maybe 5 becomes open, it shows 5 is now open. And then number 1, it shows number 1 is open. Number 1 gets occupied, goes to 5. Number 5 occupies, goes full. So all bays are now full. Just like that. Simple, straightforward indication here. Position which one is free. Right, 7 goes to 7, like that. So these resistors, well, this is simulation, this is theory. Practically, you would have to adjust the resistors because the cable itself will have resistance if it's long. Also the quality of the cable that you use pure copper, nice quality cables. You actually also avoid the adjustments of the resistors. Obviously, the feedback resistor has to be adjusted for you to have a proper indication here. As you can see, this circuit basically can be used as an alarm. So suppose it is a zone alarm, one loop here, and then there is violation there. It means it will indicate which part of the circuit is being violated. And it can also be used maybe to indicate a problem area, like in cables. Say, okay, if a cable is broken, it says, okay, that position of the cable is having a problem. And if you have a multiple fractured cable, that is, well, it will only indicate first the position nearer to you. That this problem. If you fix it, it goes to the next. Fix it, this one goes to the next. You must fix till there is a problem, and then now your cable is nice, something like that. Okay, so you convert it to use what you would want. Right, so let's stop the simulation and go to the next simulation. This now is a 7-segment indication. Yeah, so basically, okay, for the 7 segment, this circuit is identical to the previous, but the only difference is now you have a decimal output here with a active low input converted to a binary coded decimal with a active low output. Then you must actually invert it, because this 7-segment driver has an active high, so convert it active low, convert it, it becomes active high here. And then but the 7-segment driver has got active low output, so you need, if you are using an LED, a big LED that is of course 7-segment display, you would have to put a common anode display, and this indicates the position that is free, and that one will indicate the position that is if all positions are filled up, that means that section is full. This side and that side identical. Let's simulate it, run the program. Now this indication is only what the motorist will say. So what it is telling me is that bay is full, all the bays are full, and this one is number 7 is free. As you can see, number 7, where is it? Down. You can tell me number 7 here. You see number 7 is open, so open means there's no car, so it's free. I have to come to number 7. If number 3 becomes free, it goes straight to number 3. shows you number 3 is free, but it does not show me number 7. So a motorist who's coming in starts from bay number 1 will actually see number 3 is free. It's going to number 3, though it will not force you to go to number 3. You can pass on and maybe find number 5 is free and you park in number 5. And then maybe someone behind you are saying number 3 is what is free, parks in number 3. You have parked on number 5 and then parks number 3. So it shows, okay, the third motorist will actually see number 7 is free. So number 7 goes free and comes and parks number 3. So now the filled up shows now is full. So all bays are now full. So it means all bays are now full. And then maybe this number 8 leaves. This guy number 8 leaves, so it shows number 8 is free. Suppose all of them start leaving, maybe not in that order of course, but in random order, and then all the bays are now free, but it shows you number 1. Remember the priority, number 1 is shown first before number 2, number 2 before number 3, number 3 before number 4, number 4 before number 5 up to 8. Same with this one. And then if all bays are out, of course will actually show you that number 1 is free. If number 1 gets occupied, it shows number 2 is free, number 3 is free, like that. So this is how it works. And then yeah, the next one, next we stop this one and then we go for the next with 1. This one, the only difference is similar to the one with 2, but the only difference is now it is having end gates. If you would want to know and learn about gates, I have posted a video on traffic lights controller, which is a very good lesson on logic gates. Not the one with the PIC, but the one with logic gates. You can check on that one. Right, this one actually has one 7-segment display, and when the difference is and it's full, it's to start to flash. So let's see what happens here. Same circuit here on the sensors. So what it is showing me is actually all the bays are full. It will show me 0 and F flashing, interchanging. So all bays are full. If it's flashing like that, all bays are full. Well, the motorist will have to learn, maybe somehow on the codes. Say okay, if it's full, it's full. 0, maybe we'll say okay, 0 parking bay, and full, F for full. Right. If 1 becomes free, it says number 4 is free now. The flashing is slow because of the computer actually, but actually in practical terms the program is running it flashing at actually 2 Hz here. If I close other programs here, it will start to actually flash faster. Right, so this one is still full, but here bay number 4 is actually now free, and then say bay number 7 is free, goes to free. If all are free, to actually show like the other one, bay number 1 is actually free. We only see bay number 1 is free, but the other ones may be free. But if bay number 1 gets occupied, it shows 2 like that, in that order, the same like the other one. The only difference is it is 1 and it flashes. This one flashes. Okay, right. You can improve it, you can change it to suit the way you see fit, but this is how it works. And one other thing that I normally would not mention on my videos is the powering active components. Please power them. You must power active components. That's the electronics part that I say you must actually be familiar with electronics. So these components are powered, and what level? 5 volts for this level, you have to know that. And this one, the 74 series ICs, also 5 volts, so you need a power supply for this one. It's the 7805 maybe you might have a 12 volt supply here, and then you put a regulator 7805. There is enough literature of how you power microcontrollers and ICs. These CMOS ICs you can power with 5 volts, of course, yeah, because the levels must be of the same. That's the theory of electronics, and you must know that. This is just a description of how this circuit would work, and it is working. And here is the program. There is a program there. Of course, we will not open and actually learn about how you simulate, because every simulation is different. So yeah, that's pretty much about it. And okay, I think I've said much about it. You learn about every micro, how to program it and do it better than I have done it. So any feedback, any comments, here's my email, and I thank you. Enjoy electronics. Have a good day and good life.